Righto, let's get this show on the road. Greetings, everybody. If you can just click the next slide, please, Daniel. Uh, Thanks for everyone who's already joined us. Another uber popular webinar. I'd like to begin today by acknowledging the traditional custodians of the land where I'm dialing from today, the Yagara and Ugamba speaking people. And I'd like to pay my respects to everyone, all the traditional owners dialing in from all parts of the country. And I think at last count, we've got 649 registrations for this webinar. So very exciting. If you could just, before we dive into the proceedings, Daniel, if you could click the next slide, please. Look, this is number 6 of our Stormwater Fundamental series. So if you're keen to register for the future ones, and you haven't already, I know a lot of people have, please jump on the link there. Obviously, we promote it on the website, but also our newsletter. So if you're not already subscribed to that newsletter, please do so. So we're doing obviously these webinars and a few others for the remainder of the year as well. Next slide, please, Daniel. And just a reminder, folks, Peter and Daniel are going to do a little bit of a presentation about gross pollutant traps. But if you've got any questions you'd like to ask any of these experts and legends, please put them in the Q&A panel. And we always get asked this, but the slides and recording of today's session will always be made available at the oceanprotect.com.au website. Give us generally 2 or 3 days and it'll be up there. And again, if you've got any CPD form requests, and we get a lot of them, please email them through to that email address there. But just be a little bit patient because it is a bit of a time-consuming process currently. We're hoping to streamline it in the near future. Next slide, please, Daniel. But look, without further ado, obviously it's exciting to see these 2 gentlemen making their webinar Stormwater Fundamentals debut in this for this year. But no strangers to the Ocean Protect team. Daniel is our business development manager and specifications engineer. He comes with a wealth of experience. The biggest challenge, I think, for Daniel today will be keeping his conversation down to a minimum. He told me earlier he could talk for 4 hours on GPTs, and I said, well, we haven't got 4 hours. We've got a little bit less. But look, it's great to have him on the Ocean Protect team. He's been with us for over 6 years now. And obviously Peter. Peter is the Queensland Specification Manager and has been with Ocean Protect for over 10 years now. And both of them have a wealth of knowledge when it comes to gross pollutant traps, which they're going to share with us today. But just a reminder, if you do have any questions you'd like to ask any of these cool cats, please put them in the Q&A. I might pass you over to them now. So I think, Peter, are you kicking off proceedings officially?
Yeah, I believe so. So
Cool.
The agenda for today, guys, is we're going to quickly run through some general information about gross pollutant traps. Quickly, what is a gross pollutant? The history of gross pollutant traps, the different types of gross pollutant traps that are available in the market currently, and the key design and management considerations when you are looking at specifying or using a GPT on your project. What is a gross pollutant? The CRC defines a gross pollutant as debris greater than 5 mil. GPTs have been commonly used throughout Australia since the early 90s, and they typically target gross pollutants, sediment, and oils in non-spill situations. They can capture finer sediment than the 5 mils that we mentioned as gross pollutants as well, and they're a good primary treatment option for your projects.
All right, thanks, Pete. Now, the 97 CRC report, which is pictured there, is first introduced a first proprietary GPT. It was actually invented by 2 retired Australian engineers down in Victoria in 1992. It was also the first GPT that was really tested by a university at all. It contained a separation chamber, shown there. It was also contained a separate sump, shown there, and it incorporated a indirect screening technology that was commercially available from about 1994. They were easily retrofitted into existing drainage networks. Many of the coastal councils around Australia installed a lot of these throughout the 1990s and the early 2000s. It was part of the Stormwater Trust grant process around then, and also led to the preliminary development of council-based stormwater management plans and reports that we can sometimes see today. They are also sometimes referred to as a primary treatment device. This came about because of the 3 different categories, primary, secondary, and tertiary, that was introduced and used by New South Wales EPA, Victorian EPA in the 1997, 1996, and so on. Today, a lot of products actually span across multiple categories, so therefore they're not that useful, but GPTs can still be referred to as a primary treatment device. Before or prior to these proprietary GPTs, councils often needed to rely on these direct screening trash racks. You can see a picture of one there on the left, and also some floating booms on the right there. These frequently require to be serviced in order to be maintained to be operational. They only ever captured a small proportion of the gross pollutants, and the trash racks in particular there, looking at that arrow there, they were typically vertical bars around about the 40 to 100 mil spacing, and they had to be physically raked quite often. All right. Later on, we're looking at the 2010 definitions. You had that most GPTs were defined as being really good at capturing gross pollutants. In fact, there's hundreds of reports, industry reports, and product reviews that are available on different products, all confirm the effectiveness of GPTs to capture gross pollutants to some degree. As seen in the pictures here, you can get a lot of different gross pollutants that meet the 5 millimeters in 2 dimensions categorization. Some of these reports also highlighted that GPTs can remove associated pollutants. Now, associated pollutants are essentially pollutants that you remove when you actually capture another pollutant. So the GPT report in particular mentions that, and there's a caption just there. And in particular, if I focus on the highlighted section there, you can see that they also make reference to particulate bound associated pollutants. But like many of the other reports that are available on the market, they don't qualify necessarily how much of each pollutant the GPT can actually remove. And therefore, to better understand the overall performance of a GPT, you need to really know the different types of GPTs that are available on the market. And I'll hand back to Pete for that.
All right, we'll go through the 5 main types of GPTs that we see or have seen historically. Gravity separators, direct screens, hydrodynamic separators, others or combination style units that use 1 or 2 of the other categories, and indirect screening GPTs. Thanks, Dan. It's a picture of the 5 main types and some images of some different GPTs that fit into those categories. Type 1 are your gravity separators, typically using baffles. Internal baffles that elongate the flow path through the system and promote gravity, dropping the sediment and pollutants to the base of the system. They typically target hydrocarbons, metals, and sediments, and it's really important to consider what your target pollutants are for your particular project or site when you're picking which type of GPT you may want to use. Second type is a direct screening style GPT, such as the vertical trash racks that Dan touched on earlier. And we also have the pit insert style GPTs, in our case, our Ocean Guard. As pictured here, they capture debris coming in through a grate via surface runoff. Next type is your hydrodynamic separators, basically creating a vortex inside the system to promote sediment to drop to the base into the sump. And they're often used for car parks and industrial sites where litter may not be a key pollutant, because they really target more of your hydrocarbons and your sediments. Next type is the combination style units. Basically, they can target hydrocarbons, coarse sediments, fine sediments, and some litter. Combination units use a combination, hence the name, of some of the other types of GPTs that we've just spoken about. Often hydrodynamic and baffles are used in conjunction, as you can see the image on the bottom right of the screen at the moment. Or you can also have indirect screening and hydrodynamic functions in the one GPT. The image at the bottom right is a Vortec unit. Sorry, just go back down, thanks. Which combines hydrodynamic separation and baffle walls. And it can be quite handy when you have sites with shallow depth to inverts. Last type is indirect screening GPTs. They've been around for a while now. They're probably the most popular GPTs, and in my opinion, deliver the better outcome. They target a wide range of pollutants, including litter, debris, sediments, and hydrocarbons. They use a continuous deflective screen, which is non-binding, therefore more robust in delivering a better outcome. The Ocean Save unit, which is the graphic there in the middle of the screen, is a continuous deflective screening GPT, which is also non-blinding. Yeah, and there's lots of these GPTs historically been installed around the world. They're very widely used.
Thank you, Pete.
Thanks, mate.
All right, now over to key design and management considerations that you may want to go through. So according to the Stormwater Industry paper of 2010, which I referenced earlier, there's 5 general categorizations or thoughts that need to be considered when going through and designing or selecting a GPT. It's not just these 5, but these are the 5 that this paper grouped together, and it's a reasonable paper to go through and teach you guys today on what processes you should consider. But let's looking at the first one. Just like buying a house, rule number 1 is always location, location, and location. So the best thing there is to work out where is the best spot for my GPT. So that's whether you're looking at a drawing, whether you're looking at a council site or whatever, you need to look at that. So you may want to consider putting them in the road, although you need to consider maintenance, access, and so on. Beside the road or the road verge might be a better option, or perhaps in a footpath, an access way, a reserve, or a park that you can see in the background of the one of those photos. Even a garden bed sometimes might get needed or used. So long as you have the space for the construction to occur, as long as you have access to the manhole covers for future maintenance, this should be all right. You should also, though, consider any other services that might be around, electrical, gas, and so forth. And sometimes you may need to consider using multiple devices if one single device in one location at the end doesn't necessarily work. Okay, that's the first one, location. So as I said, it's the most critical one. It's the one you've got to start with. Then you get into the second type, which is your removal efficiency. Now, you need to consider, well, what is it that I need to capture? How much of it do I need to capture? What targets you need to capture? Below is an example of the Blacktown City Council targets taken from their Water Sensitive Urban Design Handbook. The targets for gross pollutants is listed as 90%, and they also stipulate a 6-month treatable flow rate for all GPTs. Now, technically, Peter mentioned the indirect Ocean Save GPT before. This GPT can easily target the 90% target just by treating a 2-month flow event. So it doesn't actually need to treat the 6-month flow event. And in actual fact, you could end up with an oversized GPT by actually having such a large treatable flow rate. But the upside of this, of course, is that you treat and capture more TSS and potentially more TP when you do so. So that's okay. Step 3 or consideration 3 is also a very critical one. It's one that does require a little bit more engineering rather than just picking something out of a list. It includes the peak flow rate. It includes the treatable flow rate. And it also considers some of the other impacts, such as potential flood risk or downstream water or so forth. Now, the peak flow is a hydraulic limitation of the GPT. It is defined by the type of GPT, also the model size of the GPT, and in some circumstances, the configuration of that GPT. I would recommend that you talk to the suppliers where you look at their technical information and review these in order to get some information to help make your selection. Oversizing a GPT model to achieve a higher peak flow rate is not always the best solution. I would actually suggest that if your peak flow is substantially higher than what the manufacturer's model would normally suggest or recommend, then you may require to go with a smaller GPT and position it offline and have an appropriately sized and designed diversion chamber instead. The supplier should be able to help you out with this, or at least point you in the right direction. All right, the treatable flow rate is the next iteration on this part of 3, and it's defined really by the type of GPT that you select. Each GPT may have a different treatable flow rate or requirement for treatable flow rate, and in part, some of the other 4 design considerations may need to be considered when you're looking at treatable flow rates. For an example, different GPT types may need to treat different flow rates just to achieve the same result as far as performance goes. Now, if I look just at the OceanSave and the CDS technology GPTs, the pig on the left shows the indirect screening flow, or the CDS technology, which Peter talked about earlier. Now, this type of GPT can be designed to treat a much lower flow in the treatable flow rate and still achieve a high performance because of its non-blocking nature. Now, the chart on the right was produced in 1999. Yes, a long time ago for some of you guys. It would be easily recognised by some long-time industry people that are in the audience, like Murray Powell, Stephen Falk, and others. It basically showed the industry at the time that by diverting and treating all the flows up to the 3-month flow, so roughly where that arrow is, that you would in fact be treating around about 96 to 98% of the annual rainfall total. Now, these graphs took the university a few months to produce, and they only did them for the 7 cities that are listed there. Today, of course, you can use music, and you can crunch a whole 10 years of data in a few minutes and work out exactly how much flow volume you actually have going through your GPT. And if anyone needs any help in doing that, then do let us know. The last part of the section 3, and this is quite detailed, sorry for the time taken, is the operation of the GPT. So it's very important, of course, to put a GPT in that actually does what it's supposed to do. It's very pointless putting in or specifying and installing a GPT that just does not function. That just doesn't make sense to you, I, or the environment. The biggest one, of course, is downstream hydraulic impacts, and these really should be considered. The section example to below there is the correct configuration of a OceanSave GPT upstream of a bio, for example, although the downstream water may just be a lake, anything else, even a detention basin. Now, if the bio has drowned inlets, which this one has, which means that the water comes up below and over onto the surface, or has an EDD that is higher than the invert level of the GPT, then this is not good. Or if the flow that comes down the GPT can't exit the bio, then obviously that leads to a backing up of water and reduction in the performance of the GPT during a rain event. So, for example, this GPT here would do about 500 litres a second, and the example I took it from, the bio, does about 22 litres a second. Therefore, you really need to make sure that you do have enough flow that can travel through the bio. Otherwise, your GPT is only working for a few minutes. Okay, it's probably the biggest hydraulic error that we actually see many consultants and also council engineers inadvertently detail on their plans. So I do implore you to consider, seriously consider the actual site impacts and the backwater impacts.
Yeah, it's not always the case just with bioretention systems or detention bases downstream. It can also be the case where you might have creeks, rivers, oceans, different things like that. So you need to be aware of your invert levels of your GPT and any top water levels or standing water considerations at your outlet.
Right. The design consideration number 4 and 5 that was listed in the SIA report, they're similar, and you're looking at pollution load and maintenance of that. They're more relevant to the council engineers that are in the audience, and therefore, or to the other final GPT asset owners, if there's any of those in the audience. The size of the GPT pollution volume in the sump or the offline storage area, it needs to be large enough for 6 months and or up to a year of pollution load. You don't want to have it much more than a year. You don't really want it much less than 6 months. Otherwise, you're cleaning it too often. And most GPT manufacturers have storage volumes that fall into this area and are adequate for the model size, that you've actually chosen. So if you size the GPT right, you generally size the pollution loading holdings area correctly. Now, music can also be used to estimate the pollution load. All you do there is model up your catchment, look at the pollution loads on your results and so on. And but also note that the music pollution loading is conservatively high. So when you look at TSS, it's actually quite high. When you look at gross pollutants, it's actually quite high. So you can use that as a worst case scenario. Likewise for section 5, which is your design consideration of maintenance, and then subsequently that forms into your life cycle costings. So this is again more important to your final asset owner. Your Dinesh and Joshua's are in the audience. The critical thing that the engineers should be considering, though, is just to ensure that all GPTs can be maintained. And if you want to see some examples of ones that have never been considered that way, I can show you some photos there of ones that you can't actually get access to, which is a bit pointless. It's also worth noting that GPT maintenance costs are generally similar for all the different types of GPTs based on the volume that you're taking out and that access and so on. So the maintenance costs may not necessarily be quite relevant to you as the engineer, unless you're really considering comparing, say, the treatment using multiple small baskets, and comparing that directly with, say, a single GPT down at a downstream location instead. So, anyway, that pretty much concludes our presentation, unless Pete's got something more to comment on.
Nothing more to add at this stage. Just generally, if you guys have any questions about gross pollutant traps, I guess you can contact myself or Dan. We're always available to offer our assistance, and guess we'll go to some questions that Brad will facilitate for us at the moment.
Yeah, thank you, gentlemen. Bang on time, would you believe? I can't believe Daniel Page, first time for everything, But and look, just a reminder, folks, if you do have any questions you'd like to ask Peter or Daniel, please put the questions in the Q&A panel. And I see a few people have put questions in the chat, but it's a lot easier for us to track the questions and answer them if you put your question in the Q&A panel. And just a reminder, folks, if you just go to the next slide, actually, Daniel, please. The recording and slides from today's preso will be made available on the oceanprotect.com.au website. And if you do have any CPD requests, please email them through to the email address that hopefully Daniel will show on the screen. Otherwise, he'll be asked for Daniel.
I can't move it. It's not going. There we go.
There you go. There you go. Yeah, so please put questions at the Q&A panel, and that's the link for the slides, and also that's the email address for the CPD form request. But look, we've already got a few questions coming through. First and best dressed from my perspective, Inna asks, and I'll read it out, can any or all of these GPTs be retrofitted into older suburbs?
I'll have it. Okay, so yes, majority of the GPTs can be retrofitted. In actual fact, the reason that most GPTs actually have a weir as opposed to a drop through them is because they started out by being retrofitted by many of the councils in the early 90s and late 90s. So it's very simple to do so. Obviously, if you've got a small drop, that helps. Okay.
Cool. Thank you. Another question from Matthew Kirby. Matthew asks, is there a minimum head pressure required for each treatment device? If so, is this information provided in the spec sheets?
I'll take this one. When you say minimum head pressure, there's a weir inside majority of our style GPTs, and you're going to have a hydraulic height, basically, that the water's going to back up to, that you need to consider in your design. Basically, each different, say if we use Ocean Save as an example, each different unit size has a different weir height depending on the flow rate that we're trying to achieve through the treatment of the continuous deflective screen. But yes, a lot of that information is available on our spec sheets, but if there's anything in particular that you don't find there, again, please reach out. We can look it up for you. Not every single thing is on the spec sheets, but yeah, it's good first place to have a look.
Cool. I might go to the next question. Shaw from McGregor Croxall. Greetings, Shaw. Shaw asks, give you guys a scenario quiz. Scenario number one, how would a GPT perform under the following conditions? Number one, flooded upstream and gravity drained outlet. And number two, flooded upstream and flooded downstream.
Flooded upstream and flooded downstream would be in bypass the whole time. It wouldn't work.
Unless you raise the weir to accommodate.
Yeah. I mean, depends how flooded you're talking. But anyway, flooded upstream and gravity outlet would be okay. Basically, depending on the size of the GPT, the inlet pipe, the weir, that would throttle or choke, depending on, I guess, your upstream levels and different things. But you would get treatment through the device if the outlet is gravity draining.
They also make a comment about sediment ponds upstream of a GPT.
Yeah.
I've only ever seen that on about 2 or 3 cases, and it's usually on a very large catchment and on a catchment that's got a lot of sediment that actually comes down and an informal channeling, so creek lines and stuff like that. So in that case, you may want to have that, but generally not.
Yeah,
Cool.
don't see that very often. Usually a gross pollutant trap does a great job of removing sediment anyway, and hence you don't typically see sediment ponds upstream of GPTs from my experience.
Cool. Question from Hayden Rosbach from Cleanaway. Hayden asks, are there any future exciting innovations in this space in the GPT world?
Well, a lot of different companies, and including ourselves and our contact partners in the US, have all tried to improve on the original that was, done in the early 90s, and we've really struggled to find too many GPTs that actually perform better than those. So we're trying, but I don't think there is a huge amount other than better configurations of some, easier constructability, perhaps, easy delivery and stuff like that. So.
Cool. Question for you, Daniel. Alison Walker from GRC Quantity Surveys asks, you mentioned inaccessible GPT for disposals. Can you post photos of these?
I think Murray's already posted majority of those, but I'm sure that I can give you some. Yes.
Yeah, I had a in-house chat with the guys in the office the other day about accessing a GPT that was in the 3rd level of a basement and was only accessible by a car lift, which makes it very, very difficult to adequately maintain said GPT. So as Dan said, location. Think about maintenance anytime you're looking at specifying or designing a GPT, guys.
Cool. A question from Quillan Vickers Noble from Bega Valley Shire Council, the council which is home to our Chief Technology Officer, Warren Jones. So greetings all the cool cats in Bega. Just a side note for the fact checkers of the world. Back to the question. Quillen asks, is any comments on what would trigger the use of GPTs? I'm assuming they would not be used everywhere.
Look, GPTs in one form or another are quite widely used these days. So, for example, I'll speak about my neck of the woods in Queensland. We have a state planning policy in Queensland for any new developments, typically over 2,500 square metres. It requires stormwater treatment. And a lot of times we use our Ocean Guard pit baskets as the GPT primary treatment device upstream of either our filtration or tertiary style treatment devices. So they are quite widely used. I know some council have requirements for best management practices and different things like that. I would consider a gross pollutant trap as a best management practice type solution. So that would probably be where you might require a trigger that needs one of these style devices.
I would add that obviously on a small catchment, a basket GPT would be a much better solution than a large GPT that you treat and you clean out annually. So that's that.
And one thing we always see, I'm not sure if Peter was commenting, but upstream of vegetated assets, like Murray Powell talked about this on the podcast around if you're putting in a wetland without a GPT upstream, you're not doing the right thing, basically. We see a lot of litter and a lot of sediment just hammering, vegetated assets. So something to keep in mind. Now, as a Dan Rhodes is asking a question, Dan from Optimal Stormwater, and I actually asked Dan to ask a very hard question for you guys. So I'm hoping he hasn't disappointed me. But Dan's question is, how can we better educate the industry on the benefits and cost efficiency of high performance GPTs utilizing CDS technology such as the Ocean Save, which maintain the required treatable flow rate by storing pollution offline, compared to lower performing devices that store pollution in the screening area, which reduces the treatable flow rate significantly? Great question, Dan.
It's a great point and a great question. How do we better educate? We run webinars like we are today, I guess.
But I suck.
And have lots of conversations with the right people. There's some very good points in that question. Anytime you've got a screening device which has the screen in the storage zone, you are going to, over time, basically build up stored pollutants, which covers that screen and reduces the treatment flow rate. The key thing, I guess, if you're, or resuspend. The key thing when you're looking at which GPT do I want to use, what are your key target pollutants you're trying to capture, and then think about what's going to deliver the best long-term goal. In my mind, it's a GPT that has a separate storage and treatment zone, a continuous deflective screen, and it is easily maintainable and in the right location.
Look, from my perspective, we can do webinars till the cows come home as well. I see a lot of councils actually, taking on board the information that you guys and others have shared around CDS technologies in indirect screens, basically mandating them. If we're talking about putting in a GPT, a lot of councils, particularly in Victoria, are mandating CDS or similar technologies. There's a few different suppliers that provide them. So I think we just need to move on past trash racks, basically. Anyway, my 2 cents. Sean Steen from Stantec asks, is there benefit installing a GPT upstream of a bioretention basin with a sediment forebay, or would this considered a belts and braces approach?
Well, the GPT would provide you with this increased performance than a sed basin, so I don't see the point. But also having 3 hydraulically would be challenging to get all 3 to work, as we've discussed with the downstream water conditions. So.
It's probably, in my mind, a really great idea to use a GPT upstream of a biobasin. Again, consider the things that Dan mentioned in regards to hydraulics in your outlet of said GPT. But anytime you're going to be assisting the bio by removing some of the larger pollutants, the litter and the floating debris, in the gross pollutant trap or the coarser sediment, your bioretention system is going to last longer and function better.
Yeah, generally the forebays are good for removing some sediments that's got through, but if you've got a GPT there, not much has got through anyway, and heavy stuff. Also, the forebays are generally more used or designed in to actually help you with your getting your flow to disperse across your bio and or bypassing around it in the extreme vents. So the actual forebay may actually be there for multiple reasons.
If you're a stormwater nerd like me, Paul Dabowski and I did a review of SED forebays in bio. So SED forebays there's a whole few different configurations. The standard one, consistent with IPWAQ drawings, does nothing. Does close to nothing. Captures a little bit of sediment that might fall out, but that needs to be removed prior to the next storm event. Otherwise, it'll just get scoured out. And we showed that bio with and without forebays had the same amount of sediment deposition. GPT with a decent sump would be far more effective. Anyway, side note, Rob Gray from Bornhorst Ward, and it might be a question more for me, because it's about squid out, which is my favourite topic. You're welcome to comment on it, Peter and Daniel. Rob Gray asks, squid out performance of ocean stave in places of ocean guard upstream of storm filters, where pit's not available for ocean guard. Will that become a tested solution? Fingers crossed. I'm hoping that's a fingers crossed, Daniel. Peter, it's hard to see because you're
it is a fingers crossed. Maybe watch this space.
Watch your space. Yeah. Look, we've got a number of, well, because 3 technologies already with squid approval. 2 aren't too far away, and hopefully there's more to come as well. So watch your space. Brett Thompson asks, how long can we expect these systems to last before needing to be replaced? This is in relation to GPTs.
It obviously depends on the type of GPT that you've got. An ocean guard is a much smaller device. It's got materials in there that are designed to last as long as we can get them to last, but there are some replaceable parts like the bags and so on in that. When you look at something like an ocean safe screen or GPT, then you're actually looking at stainless steel screens and so on that are designed to last at least 50 years ideally, but you can get them in some conditions where they only last 10 or 12, particularly in marine environments. Hence, you want to make sure you can actually replace them easily. Then the rest of the actual GPTs are normally designed for 50 to 100 years.
I'm just recognizing that we've got a lot of questions. I will endeavor to go through all of them, but Daniel, if you can just share your contact details slide, just so if people don't get their question answered and want to contact you separately, so I might move on to the next question.
Go back one, Dan.
Sana from Mitchellshire Council in Victoria. Greetings, Sana. They asked, what are the projected costs of implementing and maintaining GPT systems, and how will these costs be justified in terms of benefits to council and the community?
Look, the costs really depend on the size of the GPT that you are specifying on your project, what size the sump is in said GPT, and then how often you would need to empty that sump. As Dan mentioned earlier, typically 6 to 12 months is what we typically see for when a GPT requires the sump to be basically sucked out of all the pollution. But yeah, it's really horses for courses, depends. Can't give a blanket answer to that one. In terms of benefits to the council or community, in my opinion, reporting is the key here. So if you guys have got GPTs in your LGA or whatever, and you're sending maintenance crews out to maintain them, advertise how much pollution you're pulling out of these GPTs. That's how you're going to get people to see benefit in it.
Yeah, Peter might remember I did some work with Gold Coast City Council before joining Ocean Protect, and they were talking about it. They've got quite a few GPTs, and the amount of pollution they remove is unbelievable. And as you can see visually, it's pretty foul from Daniel's photos. But yeah, they were talking about putting their GPT pollution removal figures on billboards on the Gold Coast Highway. Didn't happen yet, but might happen. Might move on to the next question from Michael Herwardine from Mackay Council. They ask, do any GPTs include remote data transmission of operation, such as flow or full/empty, etc. I can talk to this, guys, if you like.
Yeah.
Look,
We'll
yeah, it's a
take that
great
one.
question, Michael, and it's probably relevant for Peter's previous question as well, because because it will affect costs. But look, full disclosure, this is a little bit public knowledge. It hasn't been announced to massive extent, but yeah, Ocean Protect and CSIRO have actually recently developed a GPT sensor technology to remotely assess, basically the capacity of the system, whether it's full or needs emptying, or how much pollution is in there, and that information is remotely communicated to a cloud, and that can be knowledge shared to council or whoever. A very exciting innovation. I think it'll revolutionize the industry, and we're actually probably about 2 months off releasing it to market. So watch this space. If you're keen, we're actually in the process of trials as we speak. If you're keen to know more, or maybe even be involved in a trial, or even just buy them, they'll be super cheap. I think off the top of my head, they're, I think, less than a couple $100 each. So for the cost of getting a truck out and lifting a lid and whatever, I think it'll be worth their weight in gold. So exciting times for the stormwater industry in that space. Cool. If you keen to know more, Michael, just reach out. Probably to me, probably might be the best bet. Glenn Holmes asks, we have sediment upstream of GPT. Not sure what that means.
No.
Might move on to the next
I think he might
question.
just saying that they may have sediment ponds upstream of GPTs.
All right. Thank you. Yeah, thank you,
Peter.
Peter.
Projects or whatever.
Dashana Pradhan asks, do we have any opinion on ARI basket system for sediment control? I can provide some comments on that if you like, gentlemen. Peter might remember we had a conversation about this at the Stormwater Queensland conference.
Yep.
There's, I think what Dashana's asking about is, sediment construction runoff carries a lot of sediment, and often that goes down pits. And you can put in a gully pit basket to capture that sediment. Yeah, the ones we've seen in practice are woefully inadequate, I think would be a fair description for at least some of them, without trying to avoid being sued by anyone who's got a company that doesn't. But because we could certainly put in gully pit baskets to capture sediment for construction laden runoff, if that's what you're asking there.
For example, our Ocean Guard pit insert GPTs either have a 1600 micron bag or a 200 micron bag. When you've got the 200 micron bag, you are going to capture and I guess hold a fair bit of larger sediment in those gully pit baskets. So yeah, they do a good job of sediment control.
Cool. Rishi Viner from Surfcase Council asked the same question about remote monitoring of GPT. So I'll move on to the next question. Hayden Rossback asks, where should we look to for industry? Where should we look to understand industry best practices for maintenance of GPTs? Anyone?
Well, I'd suggest Dan Wright has been doing a fair bit on that. A few others. So
Yep. Obviously,
there's a lot of different reports. They've been reporting on maintenance of GPT since in the early 90s, and they've always been saying that they need to be maintained. They're always saying that they're not. So it's an issue that's been with the industry for some time. It's still going to be there until everyone actually gets around to funding it correctly and actually maintaining these when they should be.
Yeah, look, I was just about to say, Dan Rhodes has just put in the chat. Yeah, look, for me, the key reference is also the guidelines for the maintenance of stormwater treatment measures. Dan would know that because his boss, Murray, wrote it, or at least was a lead author on it. So that's a Stormwater New South Wales document. I believe they're looking to, from my perspective, it's used in a lot of different states. I know Murray's been doing the training just recently down in Victoria, I think last week, around the guidelines for the maintenance of stormwater treatment measures. That's a 2022 document. Yeah, head to the Stormwater New South Wales website. I'll include a link to it in a sec, but that's probably for me the standout. Obviously, we've got our own O&M manuals as well for our GPT devices as well. All right. Jeff Rabich asks a question, says, look, I appreciate the seminar is about GPTs that aim to capture gross pollutant size greater than 5 millimeters. With a lot of recent emphasis on microplastics pollution defined as less than 5 millimeters, is there a gap in the market of capturing microplastics, and is it practical to capture microplastics? I can provide some comments. I'll let you guys go first. Yeah.
I'll start, Brad, if that's all right.
Yep.
The 5 mil definition for gross pollutants is a little bit arbitrary in my mind. We're talking about, a number. A lot of gross pollutant traps and devices will remove smaller particles than 5 mil. That's kind of like, just a number that we're looking at. Say, for example, like we mentioned, the Ocean Guard pit insert 200 micron bag is going to capture much smaller than 5 mil.
Yep.
Microplastics, I'll hand over probably to Brad to comment on that part.
Sure. Look, as Daniel indicated at the start as well, like some of these GPTs are really good at removing sediment. And if you can remove sediment, you can go a long way to removing microplastics. Obviously, there's different sizes, different types. Interestingly, we've actually just done an assessment with University of New South Wales, looking at what we're pulling out of some of our devices. And yeah, there's a lot of microplastics in them. That's GPT devices. So yeah, and particularly vehicle tire wear and tear, which shouldn't be a surprise, but particularly in the Ocean Guard gully pit basket, if it's got like a 200 micron filter mesh, which is our standard, I guess you'd say, we're seeing particles smaller than that being captured as well. If you're keen to know more about that, Jeff, just reach out. I'll happy to share that information. But we're doing more of that assessment as well. Yeah, so hope that answers your question. I'll go to Jeff Harris's question, and apologies that the questions they see coming through, so I'm just trying to get through them as quick as I can. Jeff Harris asks, from an asset management perspective, what is the typical GPT expected lifespan? Might be a similar question to what you asked before. I think that we might move on. Sorry, I should screen some of these questions. But hopefully your question was asked before, Jeff. Hayden Rossback asked another question. Are you seeing GPTs utilised a lot in industry versus just council/government? Great question. Anyone?
Look,
Daniel?
Varying degrees, a lot in industry. As I said, typical treatment trains that we see in the market for projects in Queensland would have some form of GPT doing pre-treatment before a tertiary treatment device. Councils do like using GPTs on larger catchments for gross pollutant capture, but yeah, that's probably the answer.
Cool. Yeah. Probably related to this, Peter, in Queensland, I see GPTs quite standard in Victoria and very seldom in Queensland. And I think a big part of it is there's a throwaway line in the Queensland Music Modelling Guidelines that says lead loads from most areas are pretty low, and I'm like,
we're talking upstream of bioretention systems here, right?
Yeah. And I'm like, what's that based on? Because I see a lot of lead in our devices being captured, and I see a lot of lead in GPT, in bio and wetlands. So I really think there needs to be more. And I know I've got a conflict of interest here, but I think there needs to be more widespread application of GPTs, or we just stop polluting more. But until that day happens,
the whole thing is we use a treatment train approach for the majority of the projects that we're providing a all-encompassing treatment option on. The reason we do that is because we're trying to capture the gross pollutants and the larger sediments upstream of the tertiary treatment devices that are more expensive, that are harder to replace, and that get impacted by those larger pollutants. So look, we do that because we maintain a lot of our systems, our jellyfishes and our storm filter cartridge systems.
Sure. A brief from McGregor Cox last another question. Talking about maintenance, is there an approach for sizing the dewatering area? Could it be similar to the approach taken for common sediment ponds? Any comments on that?
Sizing the dewatering area.
Yeah.
So we're probably talking about the sump.
Yeah, when you suck out a sump. Sometimes some areas allow you to dispose it on the ground. Some areas will insist that you take it away.
Well, I'm pretty certain in our case, our maintenance guys actually use a portable jellyfish unit in order to screen out a lot of the water only, so that we're not taking it to waste. So obviously passing it through a portable jellyfish unit and disposing of it downstream or back into or upstream or back into the GPT, and then taking away the sediment. So and pollutants.
Cool.
I would implore you do something like that. They're easy to get. I'll happily sell you one.
I'll move on to the next question. David Richards from the city of Belmont, WA. Greetings, David. He asks, are there any useful summaries of development conditions, like design and maintenance, that are effective in increasing effective GPTs on private premises that connect to offsite drainage networks?
A lot of different councils have a wide range of differences here. Some councils go to a point where they actually specify only specific GPTs that are approved in that council areas, for example. Others refer to guidelines, which are a bit more generous.
Some councils used to refer to GPTs with continuous deflective screens and different things like that, as we touched on before, as a requirement for any GPT in their LGA. A lot of councils don't go to that degree, but it really depends on the council and what their choices are.
Pete, that would have been because of the requirement for them to have multiple options available for the supply. We currently now have that with various suppliers of the indirect screens in Australia. So therefore, to some degree, the councils could quite conceivably now actually impose that requirement without any duress.
Cool. And so on topic of development conditions, the WSID compliance program that Ocean Protect and others have contributed to. If you're keen to know more about that, contact our colleague Daniel Rodder, or just Google WSID compliance program or WSID maintenance compliance framework. That includes a whole bunch of really cool development conditions to ensure the appropriate ongoing success of whatever you put in, whether it's a GPT or a bio or whatever. Rebecca Thomas from the City of Stirling, and another one from Western Australia, asks, would it be more cost effective to have GPTs upstream of a stormwater harvesting site to reduce treatment required? Where you are injecting that water into an aquifer via managed aquifer recharge, rather than treating it using a MAR site system?
Quick answers, yes.
Yes.
Majority of the times that I've seen over in the WA, GPTs are required and should be put in all over the place. In particular, if you were talking about WA, when I did a lot of work over there with infiltration, there is concern with contaminating of the aquifer over a period of time by putting untreated water into it. The use of soak wells and so on with untreated pollutants is, and particularly things like heavy metals and so on going into the ground, is not great.
Cool. Michael D. Paola from the O'Neill Group, I believe, says, asks, do GPTs provide a music score benefit? I think he means like, can we model these in music to provide a treatment benefit? Understand that these alone will not provide the music score benefit or achieve
that's correct.
Quality
so
objectives.
A
So they can be
GPT
part
will
of
not achieve all your targets for New South Wales. That's my 20 cents. Pete can talk about Queensland.
Yeah, same in Queensland. Look, you are going to get some treatment efficiencies and reductions in music using a GPT. It really depends in Queensland on the council and what their requirements are for music modelling different things. But you're not going to get all of the targets with just a GPT.
Yep, and there's different rules, obviously, for different councils. So some councils require a SQUIDEP approval, like our Ocean Guard does have SQUIDEP approval. I think it's the only GPT that has SQUIDEP approval. But I think it's fair to say that you can't rely on a GPT to achieve your 80, 60, 45 or similar targets. Even though, Peter, we both know we see it every day without mentioning any names. We'll move on. Angela Moore. I'm not sure if that's Angela Moore, one of my former previous students from Griffith University. Greetings again if it is, but if it's not, Um, I'll move on. Clarence City Council from Angela Moore says, any thoughts about the SquidApp protocol for suitable GPT devices?
There's no
Well,
reason why you can't put or test a GPT against the SquidApp protocol.
it's just the
It's
cost
just
benefit
meeting the
analysis.
requirements. So it's definitely something that anyone or any manufacturer could go through if they wanted to. Do I think it would be a good idea? Yes, I do.
The only caveat to that, obviously, is you can't test for gross pollutants using
No.
SquidApp currently. So yeah, you can
So
test
really,
for,
all you're
yeah.
doing is testing a gross pollutant trap for other
TSS,
pollutants outside of
TPTN.
that, which therefore negates the outcome to some degree, unless you're promoting that said GPT as a secondary treatment system.
Of course, ASTM International has a method for assessing gross pollutant removal, but for some reason it's not applied in Australia. So what we should do, we should develop our own lab protocol and ignore what's happened for decades in America. So that's a good idea, isn't it, Peter? Moving quickly on.
You can have that.
Question from Abar again. Is there any way to model is there any way to show a model project for all these water quality treatment products from Ocean Protect in a future webinar? Yeah, look, we're happy to do a webinar on just our products. We try and keep the fundamental stuff about more sort of general stuff, but happy to do one on that as well. Yeah, and obviously, but we're happy to meet with you personally as well. Michael Herodina asks again, are there GPT designed as relocatable / cassette / pump for use at events, festivals, etc., to insert in existing designs that may surge? That's a great idea. I haven't thought about that. So Peter, your RNA showgrounds, you know,
Yeah.
whatever the hip music festival that you go along to nowadays, you know, Taylor Swift comes to town.
Not
What
so
do we
hip.
do?
Lots of loud music is what I like. But anyway, look, there's no reason why you couldn't use pit baskets and install them and remove them. A little bit labor intensive to install and remove. There's nothing, to the best of my knowledge, in regards of an injectable cassette that you can just put in a pit.
No.
Currently, but yeah, pit baskets might be the easiest way of dealing with that question, I guess.
Yeah, the only time I've ever done a GPT and had it removable was for one of the original, 1990 trade shows down at for the stormwater industry, where or the field days thing was the council field days, where we actually buried one halfway up and ran a pump through it. So, but that was just more for demonstration purposes.
Cool. Deshana's keen to use the GPT sensor. I'll send you some info, Deshana. Shaw Abry asks, are there many examples of successful GPTs receiving combined sewer / grey / stormwater? Pete, did you want me to comment on this? Because we've looked at this. Yeah. So Daniel, yeah, please.
Right. So I actually spent 3 years or so over in the UK doing combined sewer overflows and so on, and they are different to stormwater, and therefore the actual treatment systems actually used are actually different again. So none of the products that we list on our websites and so on actually cater for that, but that's not to say that we don't have something that could do it if you had a specific need for it. So I would suggest if you have something like that, you can talk to us.
Yep.
Yours, Brad?
Yeah, look, we're liaising with an unnamed client now, looking at this very thing, treating sewer overflows. So if you're keen to know more about that, it is different to our normal, standard, but because stormwater is different to sewage, obviously. So yeah, if you can know more, just reach out, sure. Dinesh Tamang asks, what kind of GPT has a minimum hydraulic impact? What's the lowest hydraulic impact we can get for the GPT?
One that does not work.
The lowest head GPT is an ocean guard in your pits. All right. Basically, the issue with them is obviously you've got lots of different pits on lots of different catchments. So you've got lots of different locations for each ocean guard. But if hydraulically you are constrained, you cannot get an outlet because of tailwater or any conditions like that, an ocean guard pit insert is a good option. Again, I know you're going to have lots of different locations that you need to lift a lid and maintain. but sometimes that is the best outcome that you can come up with. A smaller GPT, say an OceanSave 0606 style unit, you might have a 300 mil weir in that system. So you're going to have water backing up around about 300 before it has the internal overflow. But yeah, the bigger size units have a higher weir because they're pushing more water through a bigger screen.
All right, I know you guys can both talk about GPTs all day, and I'm just going to cut it off now. We've just gone a minute over time. If anyone has any further questions, or we didn't get your opportunity to answer your question, please reach out to Peter and Daniel. I can personally vouch for the fact that they will talk about GPTs to the cows come home. Just a reminder, folks, if you haven't already registered for our next webinar, just jump on the Ocean Protect website. All the slides and recordings will be made available on that website in the next couple of days. On behalf of everyone dialing in today, big thank you to Peter and Daniel for sharing their time today. Wonderful presentation, lovely feedback we're receiving from everybody. So thanks, guys. Always great to talk about GPTs and saving our waterways from pollution. So without further ado, I wish you guys all the best with the rest of your day, and hopefully see you sometime soon in person.
Thanks, everyone.
Yep.